Yesterday, I sent a couple of emails to our RapidMiner users asking them for some help. More about this later. But one of those emails actually triggered a conversation about how to select the best machine learning model for your data. And it was interesting because this person, he asked me, hey, my colleague recommended this model type to me, and that's also what's used in this industry. Can you confirm that? And no, I can't. Because frankly, that doesn't mean anything if I don't know your data, if I don't know exactly what business problem you want to solve. So instead of confirming this kind of like industry standard or a recommendation from a colleague, I actually suggested to follow a very simple framework, and here it is. So the first step you should do, instead of just picking whatever you think is the best, you first of all should think about something I would call a fitness function, something which you can use to objectively measure how well your models work. Could be the accuracy, could be, if you're in classification, could be something like precision or recall, or relative error for a regression task, whatever it is. So you need to define how to measure the quality of models first. And it should have some meaning for the problem you want to solve. Now, the next step, you should actually just try a couple of models and change their parameters and see what works and what doesn't work. And still there's a bit of a problem here because you don't know exactly what model you can actually use for the type of data you have. But there's good news. You should check out this website, mod.rapidminer.com. This is a really cool website where you can define some of the properties of your data and you will get recommendations which models most likely will be applicable to your data. So now, very important, you need to correctly validate your machine learning models. This is actually the most frequent type of mistake I see for most practitioners. A lot of things you can do wrong there. I wrote actually a 26-page white paper on this. I will put the link somewhere. I think you should check it out because otherwise all this has zero meaning if you're not correctly validating the models. So while you're doing this, you try those different candidates, you will learn something. You will see that some models actually will perform better than others. If you see, for example, that a k-nearest neighbor model with a high value of k performs better than k-n-n with a low value of k, that can tell you something like, well, probably the underlying problem is a little bit more linear. So linear models might be a good thing to try out. So identify those shortcuts and prune the search space a little bit. But at the end of the day, you will try out all your models, and some models will perform better than others, and you should actually have an opinion, you should pick your model. But here's the interesting thing is, it's not always the case that the best performing model according to your original fitness function is really the one you should go with. Sometimes things like understandability or computation time might be very important here as well. So consider a lot of those models and not necessarily only go with the one which is the most accurate one. Alright, so it's an easy framework to actually make the right pick instead of just following some recommendation from somebody else. You should follow this framework, but it's also a little bit of work. Another piece of good news, you could also just use the new RapidMiner Auto model, which actually is doing all of this for you, and it's so much easier, so check it out, please. Last but not least, I mentioned this conversation in the beginning, that I asked a couple of people for help. I will do this again now. So, if you're a RapidMiner user and you want to support us, please go to kdnuggets.com. There's a vote for the data science platform you're using, and if you're a RapidMiner user, please support us on this poll. Thank you very much.